Alright, so second day of special products of polynomials. Now yesterday we talked about sum and difference patterns and square of binomial patterns. I wanted to touch on the sum and difference pattern one more time. So just a quick reminder that a plus b times a minus b. So we're looking at exact same terms. A is the same in both, b is the same in both. Well, when you multiply it together, recall that those middle terms cancel each other out, so you're left with just a squared minus b squared. Alright, so I wanted to look at a little bit of an uglier problem, one with fractions. I know some of you guys still have issues, but let's look at it. So a is x, b is 3/4. Recall, don't worry about the signs. Alright, so we're looking at the sum and difference pattern. All it's telling us is a squared, so x squared minus b squared. Alright, well, x squared is easy enough. X squared minus, when you have a fraction squared or raised to whatever power, you just do what it's telling you for the numerator and the denominator. So 3 squared is 9 over 4 squared, 16. And you're done. X squared minus 9 over 16. Alright, here's one. I want you to hit pause. You give it a try. 2 over 3 times x plus 6 over 5 times y times 2/3 x minus 6 over 5 y. Alright, again, hit pause. You notice the A's and B's are exactly the same. It's just a sign in between. Hit pause. You give it a try. Alright. So A is equal to 2/3 x. B is equal to 6 over 5 times y. Alright, so again, looking at the pattern, looking at this pattern here, it's just telling us whatever x is, whatever a is, square it. A is 2/3 x squared minus, and again, whatever b is, we're simply going to square it. So put it in parentheses. 6 over 5 y squared. Now you're going to square each individual thing. So 2 squared, 4, 3 squared, 9, and then x squared is just x squared. Minus 6 squared, 36, over 5 squared, 25, y squared, and you're done. Alright, so I'm hoping that's not too bad. I'm hoping you guys are getting more comfortable with this. Alright, example 2. You ever seen those people that can do all this mental math real fast? Here's a little trick that they're doing. Now, I'm not telling you you have to do this every single time. You know what? Sometimes it's easier. Truth be told, it's easier just to get your calculator and do 18 times 22. Alright, it's just as easy. But if you look at this thing, 18 is two numbers smaller than 20, and 22 is two numbers bigger than 20. Well, if we think about this, I have 20 minus 2. So do you agree 18 is 20 minus 2? Times 22, we said was two numbers bigger than 20. Now, do you agree you have a plus b, a minus b? Alright, you have the sum and differences pattern. Alright, so then a is 20, b is 2. 20 squared minus 2 squared. 20 squared is 400 minus 4. 400 minus 4 is 396. So those people that do math real fast in their heads, this is a little trick that they're doing. They see little patterns like this, and they do it quick. All right? So there's going to be some homework that I do want you to try this. But again, I gotta be honest. During a standardized test, you're just gonna grab your calculator. Okay? So I'll give you one more. You try it. Don't just grab the calculator right away. Don't cheat. Give it a try. All right? And you can always check your answer with the calculator. All right. So hit pause. Give it a try. All right. So 47. Do we agree 47 is 3 less than 50, while 53 is 3 more than 50? Alright, so then again we have this a minus b times a plus b. Alright, so a is 50, b is 3. So I have 50 squared minus 3 squared. Well, if you know what 5 squared is, 5 squared is 25. And you're simply adding 2 more zeros. 3 squared is 9. 2,500 minus 9, 2,491. Alright? So this is how those people do that math real fast in their head. They do these little types of tricks. Again, I can't stress enough, during a standardized test, just grab your calculator. But during one of my quizzes, make sure you know how to do this type of problem. Alright, so I have example 3 kind of hidden down here. You guys in biology, I'm sure you're going to see this or have already seen this. That little drawing right there, they call it a Punnett square. Right? I have no idea who Punnett is. Not important. They call it a Punnett square. And this is just to figure out from, so let's say, like this is the papa dog, and there's the mama dog. Alright? All this is trying to show is how are offspring, the kids, the puppies, how are they going to become the colors they are? So what this problem is saying, each of the 2 dogs has 1 black gene and 1 white gene. So each dog, alright? So the papa dog here, he has a black gene and a white gene. So he could be a black dog or it could be a white dog. And then the mom, same thing, have a black gene or a white gene. Alright, so we're worried about what are the kids going to look like? What are the little puppies going to look like? Alright, so the Punnett square shows the possible gene combinations of an offspring and resulting colors. First part A, is what percent of the possible gene combinations result in black? Well, if you look at it, there are 4 squares. Oops. Excuse the sloppy writing. There are 4 squares, and the black shows up in, I hope that red shows through. The black shows up in 1 out of the 4 squares. So 1 divided by 4 is 25%. Okay? So part A, what percent of the possible gene combinations result in black? It's 25%. Now, think about it. What if they'd have asked what percent of the possible gene combinations result in the puppy being gray? Well, there's two of them. There's two gray boxes. All right. Part B. Show how you could use a polynomial to model the possible gene combinations of the offspring. Well, if we think about this. Here, we have we can write it as 0.5, that would be 50%, is going to be the black, minus 0.5 is going to be the white gene, and it's going to be squared. Now, I think it makes a little bit more sense if we write it out, because I'm not really liking that. So I think it makes more sense if you write it out. Oh, excuse me, I don't need that. So if I had 0.25, so 25%, there's that 20, this 25% is coming from right there. 25% chance that the puppy is going to be black, plus the B and the W. Alright, the B and the W is going to give us this gray. So let me see if I can use this red here. B and the W is going to be gray. The B and W is going to be gray. So I have two that are going to be that could be gray. Two chances that they could be gray. So the BW represents gray. Black and a white. Alright, they have the black gene and a white gene. Plus, now there's 25% chance that the dog is just going to be white, or the puppy is just going to be white. So 0.25 that the puppy is going to be white. Alright, so W times W, that's where the W squared comes from. Alright, so what this is saying is there's a 25% chance that the puppy is just going to be black. 2 times 25%, so or 50% chance that the puppy will be gray. And then another 25% chance that the puppy would just be white. Alright, so for you guys that have seen this before in biology, you know this a little bit more than I do. Okay, but there's how the math works even in biology.